parent function, we just pick some points to do that, right? So what if now I ask you to do this? Y equals x plus 5 squared. We've kind of already talked about this in the past, haven't we? This is considered vertex form, correct? Yes, ma'am? Anybody remember where the vertex is? Go ahead, babe. You're close. It's out here. 0, so not 5, 0, but negative 5, 0. Because remember, in vertex form, this is x minus h, right? Okay, and a lot of you guys ask, well, Mr. Roberts, I see a 5. Why is it negative 5, right? Let me explain. Okay, so understand, okay, our original parent function looks like this. Then we are moving it, instead of being here at 1, 2, 3, 4, 5. Guys, it's the exact same graph. It's called shifted. It's shifting, right? It's transformed to the left 5. Why? Why did it move left 5? The reason being is, here's what my original function was x squared, and we had these values. We just showed them on the previous slide. Correct? Is everybody there with me? Now, what I'm going to do is show you this. What happened from this point to this point? Which way? It went left 5. So notice watch this. I'm going to move all these points left 5. Okay? Does that make sense to you? What's negative 2 minus 5? Negative 7. What's negative 1 minus 5? Negative 6, negative 5, 2, 4, 3. Does everybody understand where I got these values from? All I did is took the x values over here and moved them from the left over 5. Now watch. Okay, guys, I'm going to tell you something. These y values here are going to be right here. Let me show you why. Ready? Negative 7 plus 5.
Well, that's negative 2.
Negative 2 squared is
4.
Negative 6 plus 5 is negative 1. Negative 1 squared is 1. I didn't do that all. Negative 5 plus 5 is 0. 0 squared is 0. 1 and 4. You see how we got the exact same outputs, but we had to just move the graph left 5. It's the exact same graph, but it shifted left 5. Right?
Just the x is negative 5.
Because this talks about what we call this is a horizontal shift. We move horizontal. Okay? And notice, the reason why we're actually over here, what value of x makes this guy 0? Negative 5. Notice? And what value made this guy a y value of 0? It was 0 at first in our original function, right? But what value makes him 0 now? Negative 5. So therefore, then we adjust the other value to get the same y value. Okay, let me state that one more time, because this is a big idea today. Okay, this is called a horizontal shift. Okay, the reason why it moved left 5 is because that's the value that makes the inside binomial 0. Okay, is everybody with me with that? So notice negative 5 plus 5 get me back to 0, didn't it? Notice, you see how all my y values are the same? It's because I wanted them to be the same, so it just shows the exact same graph, just shifted, right? So therefore I found the value that got me back to 0, and then I did the same thing. I moved all these guys in the same direction that I had to go. Is everybody with me on that? That's called a horizontal shift. Okay? With me? So one thing I always like to say, anything on the inside here, let's do one more example before we do it. Okay? Now I'm going to do my parent function again. Parent function is just what it looks like with nothing done to it. That's just the x squared. And this is what it looks like, right? That was our parent function, correct? Everybody there with me? What do you guys think this guy is? What are we giving him? we're still moving right and left. Anything on the inside, you might want to write this in your notes. Anything on the inside is considered things done with X. So therefore, it's horizontally. You're affecting it horizontally. Okay?
Wait, can you repeat that?
No problem. Anything on the inside involves X's. So therefore, that's moving you horizontally, left to right. So, can somebody tell me what would be the values of my T-chart down here for this guy?
Simply.
Same thing. Will give me -2, -1, 0.
No.
You missed it. 1, 2, 3, 4, 5. How did you get that? You were right. Can you explain how you did it for me? Because what I do is I have to, just like I did last time, I subtracted 5 to all my values, correct? Because we shifted left 5. So therefore here we're shifting it to the right 3 as Spy said, so therefore I'm going to shift all these values to the right 3. Now notice when I plug them back in, what's 1 minus 3? -2. -2 squared comes back still at 4. 1, 0, 1, 4. It still gives you those exact values. Right? That's called the transformation. We are transforming this, follow through, in this case 3 units to the right. Right? So here was our parent. Here's our shift. Exact same graph, just shifted to the right 3. Does that make sense? That's called a transformation. That's a horizontal transformation. What other kind of transformations do we find about? Vertical ones, right? Yes, sir.
But that's the shift from like
The
0 to
origin. From the original, or what we call the parent function.
Alright.
X squared, because notice this, as soon as we see this squared here, that automatically tells me that it's still an X squared. Right? It just tells me, okay, I'm taking this basic parent function and then doing what? Shifting it to the right. Does that make sense? Yes. This right here, they'll give it to you. That's what they'll give you. So this is what we call our parent function. Anything that is X squared has this type of shape. We studied this, right? A little bit earlier. Okay? Now, other things can make it fatter or skinnier, or move it to the right, left, flip it down, whatever. But it's still a parabola, which is its parent function. Okay? So then we're asking ourselves, what does this, and then we move it to this, what does this do to it? Without having to just plot any points we want, we already know, Jake, that we can just move these X values by 3 to the right, and it'll give us the same Y value. Okay? Because ask yourself, what value makes this guy 0? You don't have, the goal is to show you what the graph looks like. So what I like to do is always start with parent and then transform. I would like you to try to stay within the same Y value. Now I'm going to blow your mind in just 1 second. Okay, should we try one more and let you guys do it? Really quick? Okay, so you guys tell me, what would this guy